Hi, I'm Miss Hall, and this is Lesson 73, Reference Angles and Using Reference Angles to Evaluate Trigonometric Functions. We begin with reference angles. Let theta be an angle in standard position. The reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. I'm going to add a fourth diagram to this definition. And I'm going to put an angle in standard position where the terminal side is in quadrant 1. So theta prime is formed by the terminal side of theta and the x-axis. So the terminal side of theta and the x-axis is theta prime. In quadrant 1, theta and theta prime are equal to each other. This is the only quadrant that happens in. So now we have an example in quadrant 2. Let me think of an angle that would end up in quadrant 2. Let's say that theta is equal to 100 degrees. Okay, so that's in quadrant 2. The terminal side is in quadrant 2. Theta prime then, right, the angle formed by the terminal side of theta and the x-axis is going to be 80 degrees. Okay, these are going to add up to 180. Let's do an example of a theta with the terminal side in quadrant 3. So it has to be past 180. Let me set theta to, for example, 200 degrees. So that's 20 degrees past 180, which would mean that theta prime would be the terminal side to the x-axis. That would be 20 degrees. And finally, in an example where theta ends in the terminal side is quadrant 4, it has to be more than 270. Let's make it 300 degrees, right? These are all just samples. If it was 300 degrees, then theta prime would be 60 degrees. That is the angle formed by the terminal side and the x-axis. There are formulas below these diagrams. I don't memorize them. I just memorize that the reference angle is the terminal side to the x-axis, never the y-axis, to the x-axis. Example 3, finding reference angles. Find the reference angle theta prime for theta equal 5 pi over 3. Okay, so they're giving us the angle in radians. I work much better in degrees, so I'm going to go ahead and convert these radians to degrees. 5 pi over 3, to convert that to degrees, I multiply it by 180 over pi. Get rid of the pi's. 3 divided by 180 is 60. So 5 pi over 3 radians is the same as 300 degrees. Now I need to sketch this. So if theta is 300 degrees, it is past 270. I will mark my coordinate plane. That's 0 degrees, 90 degrees, 180, 270. So 300 is 30 degrees plus 270. And theta prime is the angle formed by the terminal side and the x-axis. This angle, well, a couple of ways I can tell that theta prime is going to be 60 degrees. One, because this is 300 degrees, so to get it that last way is 60 degrees. If you don't see that, you know that the x and y axis are perpendicular. They form a 90-degree angle. And 300 degrees is 30 degrees past 270. So I know that 30 degrees plus theta prime equals 90. Therefore, theta equals 60 degrees. Okay, well, unfortunately, I'm not done because they gave me the angle measure in radians, so I should give the answer back in radians. So to convert from degrees to radians, I multiply by 180 degrees. Sorry, pi over 180 degrees. I can put 60 over 1. This is really 3. and I have pi over 3. So theta prime is pi over 3, which now I'm seeing, oh, the other way to know that is if I were to mark the radians on my coordinate plane. So this is pi radians is 180 degrees, therefore 90 degrees is pi over 2. 270 is 3 pi over 2. 360 is 0 pi or 2 pi once you go all the way around. So if I were looking for what do I add to 5 pi over 3 to get 2 pi, and that's pi over 3 to make in total to go 360 degrees. That is A. For B, you do the same thing, but now our reference angle, our theta, yes, our theta is negative 130 degrees, and we're going to find the reference angle. So let me draw, we're going negative 130, so we're going clockwise. This is 0 degrees, this is negative 90, this is negative 180, negative 270. So let's see, negative 130 is about there. So this is theta negative 130 degrees. And so what I'm missing to get to that negative 180 is 50 degrees. Therefore, theta prime is 50 degrees. If you needed to see an equation, if that is helpful for you, I know that negative 130 is 40 degrees past negative 90. And again, the axes form a 90-degree angle. So if I have 40 degrees plus theta prime equals 90, therefore theta prime is 50 degrees. Reference angles allow you to evaluate a trigonometric function for any angle theta. The sign of the trigonometric function value depends on the quadrant in which theta lies. So signs of function values. Let's focus on this diagram. You should be able to recreate this from scratch. So we have quadrant 1, 2, 3, and 4. And I'm going to draw a unit circle. And every point, we should know from the previous lesson, lesson 72, the x value is cosine and the y value is sine. Cosine of theta, sine of theta. And what you know about quadrant 1 is the x and y value are both positive. In quadrant 2, negative x, positive y. Quadrant 3, both are negative. Quadrant 4, you have a positive x and a negative y. And what this should tell us is in quadrant 1, for example, the cosine, which is the x value, is always positive. Cosine of theta is always positive. The cosine in the second quadrant is always negative because cosine is the x value in a unit circle, and that's negative. In quadrant 3, the cosine will be negative, and in quadrant 4, the cosine will be positive. It is just the sign of the x value. So we can do the same with sine. The sine is the y value. Quadrant 1, sine will always be positive. Quadrant 2, sine will always be positive. Quadrant 3, now we're getting to below the y-axis, so sine is negative, and in quadrant 4, sine is negative. Final trigonometric ratio we're going to focus on is tangent. The tangent of theta, you should remember, is the sine of theta over cosine of theta. I memorized this by thinking to get a tan, you need more sun than clouds. So when I think about tangent in the first quadrant, let me color code this. I did sine as purple, so cosine, and I did sine as purple and cosine as orange. So tangent in the first quadrant is going to be sine, which is positive, over cosine, which is positive. A positive divided by a positive is a positive. Therefore, tangent is positive. In the second quadrant, tangent, sine is going to be positive divided by cosine, which is negative. Positive divided by a negative is a negative. Therefore, tangent is always negative. Third quadrant, we have a negative divided by a negative, which will be positive. In the fourth quadrant, we have a negative divided by a positive, which is negative. Okay. A couple of things. You're going to notice that I never mentioned cosecant, secant, and cotangent. We tend to focus on sine, cosine, and tangent in the unit circle, but whatever sine is, for example, sine of theta, cosecant is reciprocal, will be the same sign. Also, there is a memory technique that a lot of people use for when trig ratios are positive, and that is all students take calculus. I'm going to put this over. All students take calculus. In quadrant 1, all ratios are positive. In quadrant 2, just sine is positive. In quadrant 3, just tangent is positive. In quadrant 4, just cosine is positive. Okay. Now, let me read now. When we're evaluating trigonometric functions, we're going to use these 3 steps. We're first going to find the reference angle theta prime. We're then going to evaluate the trig ratio for theta prime. And then third, we're going to determine the sign of the trigonometric function value from the quadrant in which theta lies. Example 4, using reference angles to evaluate functions. Evaluate tangent of negative 240 degrees. Let's use those 3 steps. First step is to find the reference angle theta prime. For this, I need to draw a picture. Negative 240 degrees is clockwise. You know, it's somewhere in quadrant 2. And let's see, I know that it's 30 degrees away from the x-axis, so theta prime is 60 degrees. Step 1, theta prime is 60 degrees. Your reference angle will always be positive. Step number 2, evaluate the trigonometric function for theta prime. So we're going to do tangent of 60 degrees. Tangent of 60 degrees is the same as the sine of 60 degrees over the cosine of 60 degrees. And the sine of 60 degrees is radical 3 over 2. The cosine of 60 degrees is 1 over 2. Let me rewrite this as a division problem. Radical 3 over 2 divided by 1/2. And now I'll rewrite as a multiplication. So radical 3 over 2 times the reciprocal, which would be 2 over 1. It's radical 3. So the tangent of 60 degrees, I can write that right here. The tangent of 60 degrees is radical 3. Step number 3. Determine the sign of the trigonometric function value from the quadrant in which theta lies. So theta lies in quadrant 2. And if I remember, all students take calculus. In quadrant 2, the only trig function that's positive is sine, and this isn't sine, this is tangent. So I'm going to want negative tangent of 60 degrees. Negative tangent of 60 degrees is negative square root of 3. Expressed as a function of a positive acute angle, sine 230 degrees is equal to, I need to sketch a picture, 0, 90 degrees, 180, 270. And then we're going to end in quadrant 3. 230 degrees is 50 degrees past 180. Theta prime is not 180, it's 50 degrees. My reference angle is 50 degrees. And so I would take, this is first step. Second step is I would find the sine of 50 degrees, whatever that is. And the third step is to determine the sine of the trigonometric function from that quadrant. So if I have all students take calculus, only tangent is positive in quadrant 3. Therefore, whatever this is equal to, I'll want negative sine of 50 degrees. It's going to be equal to, the sine of that is going to be a negative sine of 50 degrees. And that is why the answer is 2.